whichever one in the notes that you think is going to be most helpful. I'm going to go with the vertical asymptotes, but if you like the points better, that's fine. So for the vertical asymptotes, this one ends at positive pi over 4, and this one begins at negative 3 pi over 4, minus a negative turns into addition, and pi over 4 plus 3 pi over 4 is going to be 4 pi over 4, which then simplifies to pi. So the period is pi. And relate them to the change we expect to see in the parent function. So there is what appears to be some nice grid points at negative pi over 2 comma negative 1 and 0 comma negative 3. And these are symmetric around that dot that I colored red earlier that I could have used to find the period. If we go back to the parent graph of tangent, we are expecting the tangent parent graph to go through the origin, and halfway from that middle origin point to the next vertical asymptote was where we had the other nice point for graphing the parent graph of tangent. When the angle was pi over 4, the value of tangent of pi over 4 is 1. Going to the left from that origin point at negative pi over 4, tangent is negative 1. On this grid, I use 2 boxes to be 1 unit for the y-axis scale because I did that for sine and cosine. That's just a choice I made. You can make whatever choice when you get to pick the scale, but when they give you the scale, you have to make sure you follow what scale they give you. So we're expecting to see halfway between this middle point and the vertical asymptote a point that's 1 unit up, however many boxes that may be, and 1 unit down. And that is exactly what we see here. Here's the middle point, and halfway between that middle point and the vertical asymptote, there is a point that's 1 unit down, but it is down to the right instead of down to the left. To the left, halfway between that middle point and that vertical asymptote, we do see a point that's 1 unit up instead of down like we were expecting for the parent graph. So because the distance between the dot that I colored red and the dots that I colored blue are 1 unit on this scale. The y-axis is counting by ones. It could go by ones or by twos or by a half, so you have to check every time. But these are 1 box apart vertically, and that is 1 unit on this scale. That tells us that absolute value of A is 1. From the parent graph, 0, 0, to the next nice point, pi over 4 comma 1, is a vertical change of 1 unit. Here we are seeing that same vertical change of 1 unit, so it's not any taller or shorter than the parent graph, it's just got a different scale. It's got 1 box for 1 unit instead of 2 boxes for 1 unit. But that is not A, that's absolute value of A. The absolute value of A being positive 1 gives us 2 options for A. Either A is positive 1 or A is negative 1. Since we see this graph going down from left to right, this is decreasing instead of increasing like the parent graph was. And we noticed that when we were looking at the pattern for the points, A equals -1 is the right choice because this has been reflected over the x-axis. This decreasing behavior actually matches better with the parent graph of cotangent, but they told me to use tangent, so I don't really have any choice for that. So absolute value of A would be +1, but they're asking for the vertical dilation A, which also includes any reflection, which here is -1. We haven't found B yet. The period and B are related, but they are not the same. For sine, cosine, secant, and cosecant, the formula is period equals 2 pi over absolute value of B. For tangent and cotangent, the formula is period equals pi over absolute value of B. Here, I don't need the absolute value because I'm writing the equation. I can control whether some things are positive or negative. The negative I need in the A because of the reflection over the x-axis. I don't need another negative. So earlier we found this graph's period is pi. So we need to solve this for B. You can start by multiplying both sides by B. On the left we'll have B times pi, and on the right the B's cancel, so it's just pi. And then divide to get B by itself. Pi's cancel on the left, so we just have B by itself. On the right, the pi's also cancel, so B is 1. C is the horizontal shift or phase shift. They also told us in the problem, along with the fact that we had to use tangent, not cotangent, it had to have a right shift. They get to control what problems they give you, and some of the pieces you have to fill in. It might be easier to do this problem with cotangent, and it might be easier to do this problem with the left shift, taking the origin point to this dot, but that's not a choice we are allowed to make. So we have to figure out where that origin point would go with the right shift, and it would go to right here. So that is a right shift of 3 pi over 4. So phase shift or horizontal shift means in our equation we need x minus 3 pi over 4. Because a change that happens inside the parentheses with the x does the opposite of what you think. Subtracting, you would think, makes the graph move left, but it actually ends up making it move right. And then the D from the middle or the midline or the vertical shift from earlier was -2, because it went down 2.